I am Chris Hahn, and today's webinar is going to be on air sealing tips, tricks, and details. And so that title, we always sit down, and we're actually going through this right now, planning our next project plan year. And a lot of times we come up with titles before we come up with the content, and they don't always mesh. But this one here, we're going to try to make sure we cover all of the tips, tricks, and details for air sealing that we can. And we'll also throw in some additional fun stuff. So as Brian did mention, that this is approved through AIA LUHSW, and the program description today kind of lays the groundwork. We're going to talk about air sealing and how it continues to be a great area to increase energy efficiency, and in some cases, it is a trouble spot to meet code compliance. And we'll touch on a little bit, where the codes are going from where we currently are. And in this webinar, we'll take a look at a few specific areas, mainly 5. We'll get into those in the second half, but I want to cover 5 main areas with a bonus area on where we can help tighten up these homes a little bit more, so that we get a better air infiltration number, along with increasing energy efficiency. So looking at some program objectives, we are going to touch on and review the 2015 IRC and IECC requirements on air leakage. We're going to understand the physical transition of a home with a higher leakage rate to a home with a lower leakage rate, and how that change can affect the sustainability of building components. Okay, there's a whole lot wrapped up into that one bullet point, and hopefully we do a good job working our way through that. We also want to learn why air sealing is important to the occupant comfort and health by not allowing air infiltration of potentially contaminated areas, right? So we want to make sure that the air, where we want to air seal, but we still have to get fresh air into that house, okay? So any sort of air coming in, we want to make sure it's coming from non-contaminated areas. And that's through air infiltration, whether it's through a wall at the garage, that separation, but it also includes exfiltration too, right? So we want to make sure that even the conditioned air inside of the home can be considered contaminated depending on where it might be going to. So for instance, if we have a home in the wintertime that has a high relative humidity and we have leaky can lights, that's exfiltrating from the conditioned area into the unconditioned attic, but it's contaminated with moisture, and then you have an issue of condensation or potential condensation. So it's not necessarily just contaminated exterior air that's carrying with it mold and pollen and things like that coming in, but it's also, conditioned, we'll call it contaminated conditioned air exfiltrating into areas that can, again, potentially cause issues. And then the last program objective that we have here is we want to review air sealing techniques that can help achieve a lower prescriptive standard. And that prescriptive standard is moving, right? So it was at a number 7. It is currently at a number of 5, and we're going to take a look at what might be coming down the pipeline. So on today's agenda, I kind of have broken down into four areas. We want to talk about why air seal, and a lot of times that's an easy, flat answer because it helps with energy efficiency, right? But why does it help with energy efficiency? Why does air sealing itself, that active air sealing, how does that help increase the effective R value of insulation? And we'll take a look at kind of an example of how that works. We'll look at air sealing and the energy efficiency of air sealing. I have a pretty fun case study that we'll kind of look through. And again, we'll look at a disclaimer here, but the numbers that I have in the scenario that I have set isn't going to be for everybody. It's simply for the working through this specific case study to assign numbers to it so that we're all on the same page looking at one scenario. And then we'll look at air infiltration and the code. That'll end the first half of this, where we'll go into a quick break. And then the back half of this presentation, we'll look at 5 key trouble spots in air sealing. So the first portion here, why air seal? And I thought about putting this in as a polling question, but I'm going to kind of treat it as a rhetorical question. We have the leaky boat principle. So what's a better solution? And looking at these 2 options, we have this picture over here. Keep in mind, this boat, obviously, for the boaters out there, I know it doesn't have a bilge pump in it, but we're going to assume, for argument's sake, that this boat here is set up with a bilge pump and it still has a leak, right? You have water in that boat. So what's the better solution here? Is it a better solution to a bigger boat? Thanks, Scott, in the chat pod. A bigger boat. Is our better solution a larger bilge pump, or more bilge pumps, or to fix the leak? And I'm hoping that a lot of you are like, well, geez, it'd be best to just fix the leak, right? Because once you fix the leak, you don't have the issue of water even entering the boat. So I'm going to assume that we're all on the same page here, and we're going to fix the leak in this boat. Now we have the windbreaker principle. Okay, picture this as you walking. I don't know how many had winters like this. We had a couple days that felt like this for sure, but it's snowing, it's extremely windy, and it's absolutely positively miserable, right? So what would you wear in this scenario? Would you wear a heavy cable knit sweater and just a heavy cable knit sweater? Or would you wear that cable knit sweater with a windbreaker, right? Because if you picture yourself putting on that cable knit sweater and you walk outside and it's extremely windy, that wind is going to blow right through that, even though the insulating properties of that cable knit sweater have the potential to be really, really good. It is air permeable, so the air is going to blow right through it, and it's for the most part going to feel like what John has mentioned here, a bathing suit and slippers, right? You're gonna have that wind blowing right through, and it's not going to break up that wind. Therefore, you're going to be cold. But as soon as you add a windbreaker to that, that's your air barrier. When you add that, it stops that air movement, and that effectively increases the effective R value, insulation properties of that heavy cable knit sweater, so you're going to be warmer. So I'm going to assume we're all on that same page with those two different scenarios. So then I asked the question, then why do we claim that the home needs to breathe, right? I've heard that saying many, many times. Well, we're building the homes too tight. They need to breathe. But air leakage is a significant source of heat loss through convection, through air movement, right? When you have air movement, you're going to have the conveyance of heat moving with that, right, through convection. And air sealing is often considered a cost-effective way to save energy in a house. And now that saying I've said many times. I've heard other people saying it, but we're going to put numbers to that today, because it's one thing to just say it, and I've said it many times without having the numbers to back that up, knowing that it's true. But we're going to show some numbers today that does show that air sealing it will be a cost-effective way to save energy within a house. And then our intent here is a controlled air exchange. We've heard the term, we maybe even have said the term, let that house breathe, let those exterior walls breathe. It'll help us down the road. But really we want to transition away from that. And I have said this many times, build it tight, ventilate it right. I didn't coin the phrase. I do believe we have this cited in other presentations, but I don't have it here. But it is a great terminology to build it tight, and then we want to ventilate that right. We're really going to focus on the build it tight portion today. The PHRC, and there are many folks out there who have really good information on the ventilation side of things. But for today, the scope of today's presentation is the building it tight portion. So then versus now. Old homes were able to breathe. Again, I have a lot of these things in quotes because I've heard them before. I mean, I'm sure the majority of you folks have also heard this before. But the old homes were able to breathe was not a construction technique. They were older homes, and it was a grand product of lack of air sealing building technologies, right? And those technologies are both buildings that, like the physical technologies, and also the ability to run those energy models, and the abilities to take a home that is leaky and do an energy consumption comparison with that home versus a very, very, very similar home that has a much tighter envelope, that has a lower air infiltration number. Those technologies as well, where a lot of those homes were missing that. We also had the lack of commonly used sealing materials. Technologies in as far as materials have come a long ways, and ease of installation has also come a long ways. And information and education on that has come a long ways as well. You have the PHRC here today, giving you hopefully we consider a good presentation on air infiltration and air sealing. And a lot of the product manufacturers, if not all of the product manufacturers, all have specific training needs or educational programs on how to use their exact products. Getting this education is so much easier now than it was 20, 30 years ago. And then finally, the last bullet point here that I have is the relatively low cost of heating, right? So if we're looking at that 20, 30, 40 years ago, what's the ratio, what's the percentage of homes that were heating using one of these three methods, either wood, coal, or oil? Folks don't really go that route today, right? Because we don't have a lot of people heating with wood. I'm sure we have quite a few, but the ratio or the percentage of folks that are heating their homes with wood today is probably far less than it was 40 years ago. Same thing with coal and oil. One thing that is also missing here is what happens in the summertime. You know, everybody wants to have the conditioned air now. They want to have their inside of their home at a 70-degree temperature, regardless of what season we're in, regardless of what the temperature is outside. Back 30, 40 years ago, air conditioning for the summertime wasn't really out there. We didn't have a lot of homes, as many homes. The percentage of homes was far less many years ago. So the goal of air sealing is energy savings through fewer units, smaller units, right? The solution is not more bilge pumps. The solution is not a larger bilge pump. The solution is to seal it, you know, to work with what we currently have, or even reduce it. So we want to have fewer units. We want to have smaller units, and the reduction in energy loss through convection, right? If we're going to condition that air, we want to keep that paid for and conditioned air inside of the conditioned space. We don't want that leaking out. And then we have consumer comfort by reducing temperature irregularities. You know, when you have maybe potentially a room over top of a garage, which is its own situation, but air leakage can be a major issue there, where you have in the summertime that warm air seeping into that area, again, causing really, really high temperature differences in those areas. We have a reduction in cold and hot spots throughout that home through drafts, potentially around the windows, any sort of crack or gap in that those connection spots. We're going to talk about connection spots later on. Whenever you have connection spots, whether it's the wall to the floor or the subfloor or the ceiling in the wall, they're those main connection spots where you have the potential for air infiltration, one of the key spots. You know, and then we have better indoor air quality, healthier homes. And I have a video here later on from Matt Reisinger, who talks about, you know, those contaminants coming in, whether it's pollen, mold spores, dust, things like that. We want to keep that out. Allergens, right? Some of these things you can quantitatively measure, right? The temperature, right? You know what the temperature differences are. You can feel if you have hot and cold spots. But sometimes healthier homes is hard to really put your finger on, unless you're that homeowner or that occupant inside that you may be asthmatic or have some, you know, respiratory issue. Well, you're going to be able to know, right? You're going to be able to know if those mold spores or if that pollen is finding a way to get into that house more than average, right? So we want to make sure that we have good indoor air quality. And then finally here on this list, there's many, many more things here, but in this list is lower utility bills. And again, we're gonna put some numbers to this, and we're gonna take a look at those utility bills and how we can reduce those. And even through marketing, if you're marketing in a home that, you know, has a lower air infiltration, has a tighter home, therefore your energy consumption can actually be less. So that end user's monthly payment is now, for energy bills, is lower. They may be able to throw a couple more bucks at the purchase price of the home and maybe get that granite countertop or those hardwood floors that they're looking for. Here we have a slide that talks about the end use consumption of energy in homes in 2015. And again, this is not extremely new data, but to compile this type of information takes a long time to gather it, and then it takes a long time to compile it and put it into the correct format here. So what I have the box around here is single family detached. And of these bars, it's showing that our space heating is 46%. So the energy usage in homes in the United States, 46% of that energy usage goes to space heating. 8% of it goes to air conditioning. That's more than 50%. That's 54% of the energy use in homes in 2015 in the United States, when just to condition the air inside. So if we're spending more than 50% of the energy usage conditioning that air, I would hope that we would want to keep that air inside of that structure. So moving on to air sealing, energy efficiency and potential savings. Here is where we're going to put some numbers to it, okay? So really simple slide here, but I think it really lays the groundwork that we have both fixed and variable costs, right? So our fixed costs, that's our upfront purchase price. That's our mortgage payment. That there are reasons that can change over the life of the mortgage, but we're going to assume for simplicity's sake that that's your fixed mortgage payment. That's not going to change over 30 years. And then we have our variable monthly expense. That's our operating cost. That's going to change depending on how much usage, how much energy you use, how much electricity you use, how much water you use, okay? So that changes. That's a variable that both the occupant and the builder can help reduce. So looking at this case study, the parameters of this case study, it's a 2-story home. And again, this can change, right, for what you have, but for our parameters here, it's a 2,200 square foot above grade home. It's a 2-story, has a conditioned basement. That brings our grand total conditioned area, we're going to say 3,200 square feet. Our heating and cooling system is going to be a heat pump, and it's your standard builder grade heat pump. It's not like an inverter pump condensing unit. It's your builder grade heat pump, okay? So we needed to set these parameters so we're comparing apples to apples through all of these different air tightness tests, okay? But the disclaimer here is that you may want to discuss if you do not fall within these parameters, okay? But you find that this study that we kind of ran through makes sense, absolutely you should have a discussion with your energy rater to take a look at, if we cut from 5 to 2, okay, what's that going to cost me to get there? And then what's the end user going to save? You know, it would be a great discussion to have with your energy rater. But again, these are the parameters for the case study that we're going to talk about here today. So first of all, big shout out to Chaz from Ideal Living Environments. I sent these parameters over to him, and he ran these reports through REMrate and really got us some awesome data that we can really compare apples to apples in regards to the annual energy cost usage, okay? So this first one here is 7 ACH50. That's our 3,200 square foot home, conditioned space, that is, built pre-2018, right? So this is our pre-2015 IRC, where the majority of us just did the visual inspection checklist to make sure we're passing the air infiltration. But if you wanted to go the testing route, you had to pass 7 ACH50. For this home, the annual heating cost was $1,538. The annual cooling cost was $57. That gave us a grand total energy usage for conditioning, both heating and cooling, of $1,595, okay? Now, moving to where we are today, we're currently in the 2015 IRC, and there was a modification that we all know of that allowed us to go from 3 ACH50 to 5 ACH50. So this timeline of these products being built was 2018 through 2021. Our heating cost was $1,256. Our cooling went up, right, from I believe it was 57 to 60, so it went up $3. and that leaves or puts our total at 1,316. So the cooling, it has to do with mechanical ventilation and things like that. So that's a difference from going from 7 ACH50 to 5 ACH50. That's going from pre-2018 to 2018 through now. A reduction of $279 annually, or an 18% energy consumption for conditioning space of 18%. So I think they're good numbers, right? You can put numbers to it, and it's showing a savings annually of $279. Now, this is I hope this doesn't catch a lot of you off guard, but take a look at this. This says 3 ACH50, 2022 moving forward. We'll get into a little bit more in depth where we're going with this here in a couple of slides. But for now, let's just take a look at the numbers, where we have our heating cost, our anticipated heating cost of $1,027. Cooling, again, went up a little bit to $65, but our total of $1,092 is 17% reduction from 5 ACH50, or a savings of $224 over the span of a year. But the big number here that I want you to take a look at is right here, a little bit below. That's looking at going from 7, where we were pre-2018. And I know a lot of us were already building below 7, but that was the line, right? 7 was the line, to 3, which is moving forward, a savings of $503, or a 32% reduction in energy consumption. 32%, $503 annually. And I wanted to throw this one in. This is going to 1.5 ACH. That's above code, right? There's no, I can't see anywhere on the horizon of us going that prescriptively, but above code, heating at $900, cooling at $68, a grand total of conditioning that space of just over conditioned space of 3,200 square feet. That's a difference from 3 to 1.5 of $124 annually, or a 12% reduction, right? Now there's a lot on this slide here, but we're going to take this line by line. And again, I know that some of these numbers may not fall in line with where you currently are in your business. For the building code officials out there, you know that these numbers might be, the ACH numbers might not be falling in line with what you're seeing. But again, we're just going to take some final look at some of these numbers, assigning dollar values to things that are real world, right? So this first line here is our 2,200 square foot. That's, again, above grade finished space home of $175 a square foot sales price, gives you a purchase price of $385,000, okay? So our example air sealing package for a 2,200 square foot home, and I reached out and got some pricing on this, is roughly $700, okay? Now there might be certain trades that do some air sealing. If they do any penetrations to the house, they're responsible for making their own air sealing around that penetration. But this is coming in and doing a final air sealing package on this house of around $700. So the cost of that air sealing package in relationship to the total sales price or the purchase price of that home is a 0.2% cost of the home. Or if we want to look at what that costs over the lifespan of a 30-year mortgage, that's $3 a month at 3.5%, okay? Moving on to this next line, your annual energy savings. Again, this is going from 5 to 3 air changes per hour, is roughly $224 a year, or $19 a month savings. Again, this is going from 5 to 3. So you have that potential number of $700 or $3 a month in the mortgage to get the air sealing package, but that end user has the potential of saving $19 a month, again, with that package through that variable monthly cost of the utility bill. Now, looking at your potential savings on what is the median duration of ownership in the United States, which is just over 13 years. So we're going to take that $224 times the 13 years, gives you a potential energy savings over the lifetime of them living in that home through the data provided of just under $3,000. Okay. And this last note here, I found rather interesting. That's why I wanted to put it in here. Again, these numbers may not 100% work for you. So I would encourage you to run your own numbers. Okay. And if there's a number that you're having trouble getting, reach out to us if you need an energy rater to contact. You know, we have a pretty good network. If you need somebody who does the air sealing packages that'll come in and do those air sealing packages, we can help get you in that right direction. But this last bullet point here of $503 annual savings. Again, this is going from 7, which is pre-2018, to 3, where we are going in the future, is a $42 monthly savings, which is, you know, looking at a 30-year fixed mortgage. If you're looking at $42, if they're saving that monthly in their energy bill and they want to put that into their mortgage, that's an increase of $10,000 that they could put into their mortgage, which could cover the cost, again, of their granite countertops or their hardwood floors or something that they're looking that's tangible, that they can touch, that they can feel. Okay. Again, I would really encourage you to take a look at your numbers to see how you can use this to your favor in the marketing scheme, the marketing way. So moving forward into air infiltration in the code, okay? I do have a poll for this, which is going to kind of lay the groundwork to what we're going to talk about here and maybe give me an understanding as to where we all are, right? So, you know, what were your numbers? So there's 2 questions here in this poll. The first one is pre-2018. So before we jumped into the 2015 IRC, where we had to do our testing. If you know what your average test was, go ahead and enter it. Again, this is 100. I want to put it out there. This is 100% anonymous. So I'm not going to go back. I cannot see who's answering any of these questions. Okay, but I'm just curious to know where we are. And then the second question here is, you know, 2018 to present, where you have to have that blower door test to show compliance for the air infiltration testing. So as this is filling in here, you know, we have a lot of I don't knows, which is to be expected in the pre-2018, because it wasn't mandated that we had to have testing. I'm going to wait a couple more seconds here, and as this is filling in, and I do want to share, because I think it's important that we all, you know, kind of take a snapshot and take a look at where we are in this. All right, we're going to go ahead and end that. Thank you to all who did go ahead and vote there, and we will share results. So as you can see here, you know, the pre-2018, we had a couple folks who were coming in above 7. Right? You know, you get it tested, like, ooh, we're coming in above 7. And I'm sure a lot of them had to go back in and tighten some things up. But the majority here are in the I don't know realm, because we weren't mandated to test. Okay. Moving into the second question here, we have a lot of folks going from the 18 or 29% into the 40% realm, testing in between the 5 and the 3, which would be expected. A lot of those I don't know probably moved up into that 5 and 3. But the main thing that's showing here is now we should have a baseline, right? So that should help us moving forward. So thank you for running through that. So where we are here in 2015 IECC, which is after 2018 till now, is that our air leakage is mandatory testing. The code section specifies that in the Pennsylvania climate zones, we should be not exceeding 3, but the RAC amended that in Pennsylvania and changed it to not exceeding 5 ACH 50. Now moving forward, the testing requirements for air leakage in all of Pennsylvania climate zones will move to not exceeding 3 ACH 50. Now, if you want more information on how we got to this point right here, please keep a lookout for the PHRC putting out some webinars on the UCC, kind of explaining, where we were and how we're getting into this transition here. And that transition, this is the timeline. As of now, this is the data that we have. So contracts that are signed prior to the effective date of regulation, which is changing, is going to be early 2022. We don't have an exact date yet. This is still kind of in motion a little bit. And construction permits, so any contract that was signed prior to the effective date of regulation, which will be early 2022, and construction permits applied for within 6 months of that effective date of regulation will still be under the 2015 IRC and still be at the 5 ACH 50. However, contracts signed on or after the effective date of regulation, which again will be early 2022, we do not have that exact date yet, but if the contract is signed after that, it will fall under the 2018 IRC, which is changed to 3 ACH 50. Now this timeline, this information here was pulled right from Act 36 of 2017. I'm not going to read this. This is in the handouts, which is on our website. But again, it does lay out that phase-in period. The key component that we're currently missing is that effective date of regulation. But as soon as that's released, as soon as we know that information, we'll be sure to have it out. Okay, now we're going to get into those 5 key trouble spots. And this comes out of the Insulation Institute, which is a part of NAMA, the North American Insulation Manufacturers Association. This document was provided from them. It's online, and it lays out some really good areas. And there was this quote that was put in there. This quote comes from the Home Leakage Solution by Owens Corning that says, achieving airtight structures can be a difficult task since typical residents have nearly 1 mile of exterior joints that can leak air. So this is no small feat by any stretch of the imagination. The builders out there that are air sealing, that they have somebody on staff air sealing or are contracting out, that's a lot. 1 mile of air leakage areas, and for those building code officials that are out inspecting that, that's a big job, So I thought that was really interesting to kind of put things in perspective. But let's take a look at these. So number 1 that they had listed is seal the wall sealing joint. These are those connection points, right? This is often sealed at the exterior wall because you can see this is the exterior wall. I'm going to make sure that it's sealed, but it's often missed on those interior partitions because from one side of the partition to the other side of the partition isn't necessarily going from conditioned to unconditioned space. But what gets into that wall and then has the potential through stack effect to travel up maybe through that top plate area, now you're into unconditioned space. So we're going to take a look at some of those air sealing areas or how to do that. But what's pretty neat here is you have the potential reduction here at the bottom, which is around 1.6 ACH 50. These are numbers given by this document that saying if you do a good job in sealing these areas, you have a potential reduction of 1.6 ACH 50. So here's a picture that shows an exterior wall with an interior partition coming into it. And this interior partition is running parallel with those trusses. So you're going to have nailers attached to the top of it, which gives you a really good area for air sealing. But what happens when those interior partitions are running perpendicular to the trusses? You're not going to have a nailer on top of that wall. So you have your drywall that's going to be coming up this wall, and then you have your drywall coming into it. Tape and compound isn't going to be enough in these areas. You're going to have cracking in that tape or in the compound, and it's going to be a source for air leakage. So the recommendation, and this comes from Builder Online, this article, Air Sealing Whys and Hows, written by Steve Easley, is a good, really good article. And I snagged a couple photos from it. So this is courtesy of Steve Easley through that article. But here's a really good picture of showing an interior partition that is perpendicular to those trusses and how that air sealing should take place. The next one here that we want to take a look at is recessed lights, ceiling boxes, and bath fans. bath fans is one that I believe often gets overlooked. But most units, talking about the can lights here, are airtight, and you must use an airtight cover that seals to the drywall. And I'll show a picture of why that is. And this also includes, as I said, bath fans and other fixture boxes. If there was a can light, or not a can light, but a fan box that's going in, or a ceiling mounted light, they're going to have boxes that has to be sealed around that. Sealing these areas up, again, this number depends on the number of ceiling or can lights that are being used. But you have roughly a 0.2 ACH 50 in this area. So here's a picture of this can light. As you can see here, it is airtight, right? And it's rated for insulation contact. And this has two housings, right? You have an inner housing, and then you have an outer housing. And as you can see right through that. You can see the framing in between those two housings. Now, when this drywall is installed, there we are, it's installed, you can still see that gap around that. And for this reason, the only way that you can truly seal this is if that trim plate that attaches 100% seals to that drywall. Otherwise, it's going to leak. Every single one of these can lights, oh my goodness, every single one of these can lights, and I've seen more in homes, they're all going to leak right there. So that's why it's critical that trim piece, make sure that it seals to the drywall. And here's just a photo of a bath fan, again, where here you have spray foam insulation sprayed in there that is closing up that gap. The third one here is duct boot sealing. So the duct to the boot is usually sealed, right? Because you don't want your ducts leaking. So that is usually sealed. However, the boot to the surrounding surface is sometimes overlooked. That allows conditioned air to leak into unconditioned areas, which again is roughly a 0.2 ACH 50. So here's a picture of a boot coming through the subfloor with mastic. Beautiful installation, right? This is what we're all seeing. I'm sure this is what we're all seeing. But that's pressurized. That is a supply run. It's pressurized. A lot of care is taken into making sure that that's sealed. But here's a picture of a jump duct going from a bedroom to a common area. This duct is not under pressure. So sometimes that is looked at as, wow, that'll be fine, right? But the only way a jump duct works is if there's a pressure difference, right? So this works when you do not have a dedicated return in a bedroom, the door is shut, conditioned air is being supplied to that bedroom. This is a pressure relief for that room. And with that being said, that means that this over here is going to be under pressure. So if it isn't sealed, it's gonna leak between the drywall and that opening into the attic. Okay, and that's what we don't want. We don't want to be pushing, whether it's through pressurization of the system running or stack effect. We don't want that conditioned air leaking into unconditioned spaces. Here's another photo from that same article, Air Sealing Whys and Hows, by Steve Easley, showing some duct work that's blocked out. It's completely blocked out, and then it's sealed all the way around those framing members. The fourth one here is sealing band joist, which is, again, often overlooked. And it's twice the amount, right? Because you have a top and you have a bottom to this rim board, which has a potential reduction, if sealed correctly, of 0.4. This is what we don't want to see. This is unsealed. You can seal it from the inside, and with this product here, you can also seal it from the outside. So we're sealing the top of our band joist here, the bottom of the sheathing in the band joist, but if there's any sort of overhang, that also has to be sealed, right? So you have to have some sort of, whether it's a tape or a fluid applied or some sort of a flashing that goes and covers the underside of that to make sure that that air seal goes all the way down to the foundation itself. This is typically what I've seen a lot of with sealing of that band board with this spray foam insulation top and bottom. And the last one here that I want to talk about of the five is the wall from conditioned to unconditioned spaces, even though it may look like an interior wall. So that this wall that could be between the house and the attached garage, this is not limited to what's being shown here, with it being limited to that bottom plate. It should be the whole wall that should be taken into consideration, but is often overlooked. Here we have a ceiling being applied at that bottom plate to the subfloor. And as you can see here, it's also in the field there where you have OSB joints coming together. Here's the last photo from that publication or that article on builder.com or Builder Online. That's just showing, again, that joint between the floor and that bottom plate being sealed. But again, you have all these penetrations in that wall. These absolutely have to be looked at as well. Here on the left-hand side, we have the box that does not have any sealant that are on. You can clearly see that air will get through there. Okay, this one over here, it's not the best, but it is sealed. And then for our bonus trouble spot is the transition between concrete and wood. So what I'm talking about here is the sill plate. Okay, you have your framed wall sitting on top of a slab on grade. You have your framed wall on top of a stem wall, and then you have that sill plate to the foundation. And here's a video that I want to show. It's about 3 minutes long. It's Matt Reisinger. If you haven't watched any of his videos, he does a lot of building science, cool stuff online. So we'll go ahead and watch this real quick.
On today's video, we're talking about air sealing at the framing stage. On today's video, we're going to be specifically talking about sill sealer and why it's important to start air sealing right here at the beginning of the framing stage. But let me back up before I talk about these products and talk about why we want to air seal. Number one, codes are changing and we're going to have to build a much tighter house than we did even 5 years ago. But it's important to build a tight house for several reasons. Number one, we can't ever control the indoor air if we can't control air leaking in. When air leaked into an older house, it brought with it all kinds of outdoor contaminants like pollen and mold spores. It also potentially dropped water inside our wall cavities. As I've done a lot of remodeling, I find a lot of mold on the back of sheetrock from air leaks that came in. That humid air hit a condensing surface and mold was growing inside those wall cavities. So it's really important for us to air seal. And remember, the other big benefit of the air sealing is we're sealing out those bugs. I find a lot of bugs in remodeled houses. So a tight house is a good house. Hashtag tight is right. Okay, so let's talk about air sealing specifically. You know, this is what most builders across the country are using for air sealing at this connection between the foundation and the framing. So here's our 2x6 bottom plate right here. This is what's commonly used. This does a good job of a capillary break and it provides some air seal. But if you look at that real thin foam is not doing a great job if we've got any undulation in our concrete. On the other hand, this gasket, this is going to provide a really nice air seal for us at the base of the wall. This has 2 neoprene bulbs right here that are going to crush down between the framing and the concrete. We're going to get a real nice tight air seal on there. Now, if you have this in your house, don't panic. I've built a lot of houses with this, but this is a belt and suspenders approach. As I've tried to really tighten down the air sealing on my houses and the blower door scores over the years, I've found that you need to take a multi-prong approach. So this is step one, using a good sill sealer. Step two is going to be doing something to the outside as well, where your framing meets your foundation. You've seen me do a video before with some tapes. Tape's a good option. I'm going to have a video coming out where we're going to talk about how to do it with a fluid applied. And we also want to do some air sealing on the inside. Again, tape is a great option on the inside. We could also use a caulk or a fluid applied on this joint. By doing that air sealing on all 3 locations, we're going to ensure that we're not going to have bugs, we're not going to have air leaking in there. It's going to make a much more energy efficient house. And remember, tight is right. We don't want that air to only come in when the sun is out and when the air is blowing around. This is really important to the longevity of your house, and you're never going to touch this connection for at least the next 100 years, guys. So let's do it right from the start. Thanks for joining me. We'll see you next time on The Rogue Show.
You're muted, Chris.
Thanks, Brian. All right. Hope that video came across well. I heard that sometimes it's choppy, but if you couldn't tell that by the way Matt said bugs, he's from Texas. So some of his building techniques are a little bit different, but a lot can be applied to Pennsylvania as well. So he does have a lot of great information. I would encourage you to check out his YouTube channel, see what he has. So moving on, you know how he did talk belt and suspenders approach, right? So he talked about doing some sort of a caulking on the inside. Here is, if you are using that sill sealer and you want to have that additional protection of making sure that your air seal is great between that concrete and your plate of your sill plate or the bottom plate of your wall, it's always a great idea to throw in some additional caulk in that gap to ensure a good air seal. So last section here is moving from 5 ACH50 to 3 ACH50. Thank you, Brian, for posting his buildshownetwork.com in the chat. So looking at the numbers, right, just looking at these 5 trouble spots and your potential reduction in air exchanges per hour, adding them up. So our wall to ceiling joint has the potential savings of 1.6. Taking a really good look and making sure that those trim pieces are sealed to the drywall and making sure that we're foaming around any sort of light box or bath fan that has the potential of around 0.2 ACH50, duct boot sealing, another 0.2 ACH50, sealing at the band joist, you know, all the way around. Some locations get overlooked as a 0.4 ACH50, and then sealing that wall between conditioned and unconditioned spaces, roughly 0.2 plus ACH50, which gets you, just looking at these 5 spots, has the potential to get you a 2.6 ACH50, which definitely helps out, right? So if you're going from 5 to 3, that should get you there. But as I said earlier, with running through that poll, our baseline should already be established, right? When we went from the 2009 code to the 2015 code, the majority of us didn't have a baseline. We didn't know where we were testing in at. It could have tested in at 4 ACH50, or it could have tested in at 9, because we weren't doing a blower door test on all of our homes. But since we've adopted and moved into the 2015, now we need to be doing that air infiltration testing through blower doors, the blower door test. We should all have a baseline and know where we are currently, so that'll help us moving forward into this transition into 3. Working through this summary, a house can't be too tight, right? You just have to make those additional measures to achieve, you know, that whole house mechanical ventilation. And again, that's out of the scope of this work, or out of the scope of this webinar, really diving into that whole house mechanical ventilation. But if that exhaust only, there's three choices. They're exhaust only, supply only, and a balanced ventilation system, right? And if that exhaust only option is working for you at 5 air changes per hour, you really need to take a look at that when we move to 3. It's always good to be looking at that as a good, better, best approach. And that exhaust only, you want to make sure that it's critical that it's working correctly. So take a look at your whole house mechanical ventilation systems. Seal those connection points, whether it's, you know, the wood framing to the foundation, or it's the subfloor to the wall, or the wall to the ceiling. It's those connection points that are really going to, if they're going to leak, they're going to leak the most. So pay attention to those, make sure they're sealed up, and that'll get you on your way to the 3 ACH50. Your air sealing scope of work doesn't need to be more in depth, right? Or where are you currently falling in? Do you have to revisit that scope of work? Do you have to revisit or have a conversation if you have somebody on staff that is doing your air sealing package? Do you have to pull them aside and be like, all right, let's maybe get with our energy rater, run a blower door test, see where we're coming in, walk around with maybe a smoke stick or an IR camera and find out where your trouble spots are. and then address those and then see where you're coming in. So that way we're ahead of things moving forward. Building in predictability. Make sure that in the design phase that you're detailing these connection points so that when you go out to that job site, you have a little bit of an understanding as to where you may have some air infiltration issues, but you know based on your details that you shouldn't have issues in certain areas. You want to build in that predictability and then hone in on those unpredictable areas. Have the conversation with your energy rater now. Having that up front now will definitely pay off and help you in the future, okay? See where you're at, see where you can move forward from. And then marketing. Use this to your advantage, right? Set yourself apart with building science. Know why you're doing things beyond because the code tells you you have to do it. Know why you're doing it to give them a better indoor air quality, to lower their utility bills. Set yourself apart through building science.